Hey everybody, this is Chapter 5, Measurement, Part 1. So this is the Part 1 of Chapter 5. We're going to talk about measurement today. Specifically, I think the title in the book is what? Identifying good measurement. But we're talking about measurement and what makes it good, what doesn't make it good, right? So when we're talking about measurement, the first thing we need to do is review something we talked about in Chapter 3. So here it is. A measurement is what? Go ahead and answer this question. A measurement is an operationalization. Remember, we have conceptual variables, the circles, and then we have operationalizations, the squares. There's two kinds of operationalization. They are measurements and manipulations. Those are the real-life, concrete ways of getting at these concepts that we care about. Those concepts are also called constructs. They're also called constructs. So that is why we also refer to something called construct validity, which we'll get to in just a second. But first, let's discuss this. Do you know what this thing is right there? That is a thermometer. A thermometer is a measurement. It is a way that you operationalize the concept of temperature. Now, I want you to think about this because we're going to talk about what makes something good or bad in terms of the measurement in just a minute. But temperature can be measured in several different ways. One way that you can measure is using this. I think this is by Galileo, if I'm not mistaken. Galileo's thermometer, which uses these different liquids and they go up and down, etc. Another way you can measure temperature is with a digital thermometer, right? Go outside and measure with a digital thermometer. A separate way that you can measure temperature is by going outside and sticking your hand out there and saying, I think it's 98 degrees, okay? Another one is to get some crickets. Take them outside, and I don't know if you knew this. This is real, by the way. You get the crickets, and the crickets chirp faster when it is hot and slower when it is cold. So you just count the number of chirps, and then you see how fast they were within a given minute, for example, and that will measure the temperature. Now, all of those things measure temperature. All of them measure temperature, but some of them measure temperature a little bit more precisely, a little more accurately. You would probably rather have a digital thermometer than a box of crickets. Even though both of them measure temperature, the crickets don't do it quite as well. And we're going to talk about what makes something more reliable, more valid later on. But first we need to do an example. So the example we're going to do is not about temperature, which is more of a physical science thing. Let's talk about a psychological conceptual variable, right? Instead of thermometer being measured by thermometers measuring temperature, let's talk about a measurement of a psychological construct that we've already mentioned in the past, and that construct is love. So we are going to take this is 17.com, and we are going to take this particular quiz, are you in love? Or is it a crush? Because there's this conceptual variable called love, and we want to measure it. So I'm going to take it right now. This is the measurement of love. So let's see if I'm actually in love with my wife, or if it's just a crush. Things in common, oh yeah, like children, for example. Inside jokes, yep. More serious, boy, if it could be more serious, I'd be surprised, but that'd be great. Nervous and giggly. You know what? Nowadays, I'm able to play it cool. I will admit, I'm able to play it cool. You think yourself crushing on someone? No way. No way. My wife is awesome. All right. And the rest of this, come on. Quit messing around. Quit messing around. 17 magazine. There we go. I'm thinking I'm getting a pattern here, so I'm just going to kind of go and click on these. You've never done this before, I know, but I'm just going to click on all on the left side just because, you know, time and all that stuff. All right, let's go. Whoop. We have hung out one-on-one, me and my wife. Yep. Feeling pretty strong. Come on. Oh, I might be in love with my wife. It's true. You know what? I am going to go, oh, look, here's the answers. If I answered mostly with the first column, my feelings might be the real deal. Well, not just because she's hot or she's not on the soccer team, but it might be the real deal. So that's what you do. What you do is you get a bunch of questions, you throw them up on a website, and that's how you measure psychology, right? The end. Of course not. Of course that's not the end. That's not the end. Of course that's not the end. But this was a measurement. This really was. It really was a measurement of a conceptual variable called love. That's what it was. When we look, we can map this out like we did previously. We had this concept. Let me get rid of that extra little line. We had this concept, and that concept was called love. Notice how a conceptual variable is in a circle. And we wanted a concrete, real-life way of getting at love, right? We wanted, from this conceptual variable, something concrete out of it. And so we had the 17 quiz. Okay? Now, are there other ways that you could measure love besides the 17 quiz? Well, yeah, of course there are, and we've talked about some of these before. So I could have an observer, somebody go out there and just count the number of times I kiss my wife. That would be a measurement of love. Or if I wanted to, I could go and get a heart rate monitor. Right? You get a heart rate monitor and measure the number of beats per minute whenever my wife is around. And the more beats, the more love, and it's great. Now, all of these are operationalizations of love. The question, though, and the one that you should be thinking about is, are they good operationalizations? Do they actually measure what they're claiming to measure, or are they measuring something else? Are there better ways that we could measure love? If you are asking that question, then you are asking a question about construct validity. All right? Construct validity is, does the measure measure what it's claiming to measure? Or the manipulation manipulate what it claims to manipulate? Construct validity, the construct is the conceptual variable, in this case, love. It's valid. The measurement is what we're testing the construct validity of. Does the 17 quiz actually measure love, or is it measuring something else? Now, the main types of measurements that we have are self-reports. When the person is reporting about the conceptual variable in themselves, then that is a self-report. So for example, when you ask me, how much am I crushing on my wife, then you are measuring, that's a self-report because I report it. I myself report what's going on. There are other ones though, observations, for example. So you can just watch me and see how many times I kiss my wife, for example. That would be observations. In this case, you are the one observing me and putting down the data, putting down the information. Physiological measures are what's happening to your body affected by the psychology, right? So if I am in love, right, I've got this conceptual variable love going on, that should affect my body in certain ways, specifically my heart rate. My heart beats faster when my wife is around. That would be a physiological measure. So for example, 17 quiz, self-report measure. Counting the number of kisses when two people are in the room, that is an observational measure. Checking my heart rate whenever my wife is around, that would be a physiological measure. All of them are measures. Now, whether they're good, it depends, but those are different categories of measurement that we often use in psychology. After we do those measures, however, we're going to get data. We're going to get something from it. And so we need to review the different kinds of data. Remember, nominal, ordinal, interval, and ratio. Different things can give you different kinds of data. So it's not like nominal goes with self-report and ordinal goes without. That's not how that works. Self-report can give you nominal or ordinal or interval or ratio for that matter, depending on the different measures that you have. So let's review it. A nominal example. Remember, nominal data is what you get when the data comes back and it represents a category. So for example, the 1, 2, 3, 4, 5 represent blue, red, green, brown, and yellow. So when you ask me what is my favorite color, and I say blue, and blue is a 1, it doesn't mean that a red is twice as favorite as blue, right? So the number, in this case 1, just means it's blue. It's just a different category. The number itself doesn't mean more or less of anything at all. It just means this is the category that I like the most, and that is blue. Now, determining what is nominal is going to be very important. It's crucial. For this class in psychology, it's really, really important because certain statistics have to be used in different ways when we're talking specifically about nominal data. So nominal data is data you get from any kind of measure that puts things in categories, where the numbers don't mean more or less of anything, it just means they're different. That is nominal data. You'll notice that, for example, I could ask a different question, something like, how much do you like the color blue on a scale from 1 to 10? That would give me different data because liking would be more. If I said 3, that would mean I'd like it more than a 2, right? 3 is more liking than 2. That is not nominal data anymore. That is what we call ordinal data. And I thought, there it is. I put it in the wrong order. I'll go back to that one. Ordinal data is one step ahead of nominal data. In this case, the numbers actually mean something, and they mean more of something. So, for example, when you look at this, and I say, I like corn dogs, what I would be doing here is I'd be assigning a value to each one of these. 1, 2, 3, 4. And in this case, the numbers represent more liking for corn dogs, right? So more of the concept of liking of corn dogs. 2 is more liking than 1. 3 is more liking than 2. 4 is more liking than 3. So if I give you a 4, you know that I like corn dogs more than somebody else who gave you, than if I'd given a 3, for example. Okay? Ordinal. The numbers have ordinal meaning. That is, the order of the numbers have meaning. The problem, though, is can I know that my liking for a corn dog between a 3 and a 4 is the same as the liking between a 2 and a 3? Do I know that your liking of a corn dog, if you said 3, then that means that you have exactly twice as much liking as somebody who gave a 2 or a 1? We don't know that. We just know that 2 is more than 1 and 3 is more than 2, but we don't know that the interval between those is the same, right? I don't know that the difference between a 3 and a 4 is exactly the same as the difference between a 2 and a 3. So ordinal can't tell us that. Interval can. So in interval data, we get data that we know that the numbers, the higher they go, means the more of something. But we also know that the intervals between the numbers are exactly the same. So for example, when I ask you what is your current body temperature in Fahrenheit degrees, that means that we're using interval data. Why is it interval? Well, we know that a 98 degrees is more than 97. So we know it's at least ordinal, but we also know that the difference between a 96 and a 7 and a 97 and a 98, those intervals are the same. Each interval is exactly the same. So we get interval data. The problem with interval data, though, is that when we look at a 0, 0 doesn't mean 0 of the concept. So 0 Fahrenheit degrees doesn't mean 0 temperature. It's not what that means. 0 doesn't mean 0. So that's the difference between interval and ratio. In ratio data, we have all the aspects of the previous stuff. So we know that the numbers, the order matters, right? Higher numbers mean higher amounts. We also know that the intervals between the numbers are exactly the same. And we also know that 0 means 0. So for example, in Kelvin units, temperature, when it's measured in Kelvin, that's a ratio. That's ratio data because 0 degrees Kelvin means 0 amount of heat, I believe, right? And also each of the intervals are the same, and the higher you go, the higher the temperature. Another example is time. So if I asked you how many minutes have passed since you last ate, well, if you said 7, then that would be more than 6. Okay, 7 minutes is more than 6 minutes. So we know we have ordinal at least. Interval is the difference between 6 minutes and 7 minutes the same as the difference between 5 minutes and 6 minutes? Yep, the intervals are the same. You have at least interval. Does 0 mean 0 amount of time? Yes, it does. So ratio is the same as interval, only the 0 actually means 0. Now, the reason why this is such a big deal is because when we do our statistics, you must know the difference between those kind of data. We tend to chunk them into groups. Nominal, we call that categorical. Nominal data is categorical data. So anything that's nominal, we call that categorical. Why? Because you put it into categories. Okay, I like, what's your favorite color? Blue is my favorite color. That's the category. It just is categorical. However, ordinal, interval, and ratio, we tend to chunk those together into what we call continuous, or sometimes called quantitative data. So when you hear categorical, we're talking about nominal data. When you hear continuous, we're talking about ordinal, interval, or ratio data. The reason why this is a big deal is because you cannot do the same statistics on categorical data that you can on quantitative. You've got to know what kind of data you're getting from each of your measurements. You have to. You must know what kind of data, because if you don't know, then you can't do the correct statistics. Let's move on. Let's move on and talk about validity. Remember, in chapter 3, we talked about 4 different kinds of validity. We talked about construct validity, statistical validity. We talked about internal validity and external validity. Those are the 4 kinds of validity. In this chapter, we're only going to talk about that first one, which is construct validity. Remember, a construct is a conceptual variable. Construct validity asks, does your operationalization really influence or is influenced by your construct, your conceptual variable? Does the measure what it claims to measure, or is it measuring something else? Does the manipulation manipulate what it claims to manipulate, or is it manipulating something else? So since we're talking about measurement today, does the measure really measure what it claims to measure? So for example, does the 17 quiz actually measure love, or is it measuring something else? Under construct validity, we have 3 subtypes of construct validity. So base validity, content validity, and criterion validity, they're all parts of construct validity. They're not totally separate validities, they're aspects of construct validity. So in the category construct validity, the subcategories are face validity, content validity, criterion validity. In this whole class, there are a lot of different kinds of validity that are going to get shot at you. You need to be able to say, oh, well, this is part of this kind, or this is part of that kind. Know how to organize it in your brain. It's going to help you a lot. When we want to know, does the 17 magazine quiz actually measure love or measuring something else, we're asking construct validity questions. And the way we can figure that out is to say, all right, well, let's look at the aspects of construct validity. And 3 of the aspects include face, content, and criterion validity. Face validity just means, does it appear to be measuring what it claims to measure? When you look at the 17 magazine quiz, does it actually look like it's measuring love, or does it look like it's measuring something else? Content validity, on the other hand, says, if I've got this thing called love, this concept called love, content validity says, are you actually getting all of the content of the conceptual variable? Does your measure actually measure all the aspects of love? When you think about love, when you think of everything that's part of love, does your measure all the content? Does it measure everything inside of that concept of love? That is content validity. So if I love my wife and I take this 17 magazine quiz and I say, boy, there's lots of questions. I love my wife in ways that just really were not talked about on this quiz, then I'm saying this has poor content validity. It's not measuring all of what it claims to measure. Criterion validity, on the other hand, is a behavior that should be connected with your score on the measurement. So for example, criterion validity would say, if you say that you really are in love with your significant other, then there should be behavior, a specific behavior that goes along with it. That if you scored high, we would have high amounts of that behavior. If you scored low, we'd have low amounts of that behavior. So a criterion might include kissing, for example. And so what we would do is we would look at your 17 magazine quiz, and we'd say, oh, you answered almost exclusively in that first column, therefore you must really be in love. And we have determined that when people are in love, they kiss each other. And so on the next observation, you might observe that you and your significant other together, and the more you kiss, we observe that, and we would expect that the higher your score on the 17 magazine quiz, the higher amounts of kisses. That would be a criterion validity. Criterion is a behavior that should go along with your score. Conversely, if let's say that you scored almost everything in the other column and it says, oh, you're really not in love, it's just an infatuation, maybe the criterion would be commitment, like actual getting married, right? We find that people who scored almost exclusively in the right-hand column, they didn't get married, and so therefore it would have good criterion validity, right? We would expect people who scored in the left column to get married, those in the right column to not get married, and if they did that, they would have good criterion validity. Okay, let's test ourselves out. So let me give you a question. First, face validity is an aspect of none of the above. Face validity is not a form of internal validity. It is not a form of external validity. It is a form of construct validity. And so is content validity, and so is criterion validity. Face validity, content validity, and criterion validity are all parts of construct validity. They are all aspects of construct validity. Because construct validity was not on there, the correct answer would be none of the above. Let's review some more. This is the inclusion of the other in the self scale. The inclusion of the other in the self scale is just a question where you're supposed to picture yourself, you're the self, and then whoever is your partner as the other. So I'm the self, other is my wife. And what you do is you circle the pair of circles that best represents your relationship. So if I go over here and circle these right over there, then that would be my response to the inclusion of the other in the self scale. That's what that would be. Based off of that, am I going to get nominal, ordinal, interval, or ratio data? The answer is ordinal. I would get ordinal data. And let me tell you why I would get ordinal data. What I do is I take each pair of circles and I give it a number. So this is 1, that's 2, 3, 4, 5, come on, 5, 6, and 7. So in this case, I circled 7. So that means my score would be 7. And a higher score would mean higher closeness in the relationship. 2 is more closeness than 1, 3 is more closeness than 2, etc. However, we cannot be sure that the difference between closeness between a 5 and a 6 is the same as the distance in closeness between a 6 and a 7. It's not like you're actually going in there and calculating the area that overlaps. And that's not how it goes. We just know that 7 is more close than 6, and 6 is more close than 5, and 5 is more close than 4. That's all we know. So we don't know that the intervals are the same. So this case, we would end up with ordinal data. The numbers mean something because of their order. That's ordinal data. The inclusion of the other in the self scale results in what kind of data? Quantitative or categorical? This would give us quantitative data, also called continuous. Quantitative and continuous, I'll use those synonymously throughout the class. In the book, I think they use quantitative. But this is quantitative because ordinal, interval, and ratio data are quantitative. We chunk those together into quantitative. We already determined that this is ordinal, so it must be quantitative. The inclusion of the other in the self scale is face valid. This depends on your opinion somewhat, but I would say yes. I would say that it is face valid. Face valid is a subsection of construct validity. It's just saying, does it appear to be measuring what it claims to measure? Well, if closeness is what this claims to be measuring, then this appears to actually be measuring closeness, the psychological overlap between the two people. The inclusion of the other in the self scale is content valid. Okay, now this depends also on data and your opinion. So if you believe that psychological closeness is really just an overlap of your identity of self and other, then you would say that this is content valid. But if you think that closeness is more than just kind of the idea of how much you overlap, then this would not be content valid because this only measures the amount of overlap. If you think that closeness includes other things like caring or thinking about somebody or whatever else, then this would not be content valid because it doesn't have enough, it doesn't have the content, the aspects of the conceptual variable closeness. The inclusion of the other in the self-scale is criterion valid, yes or no? Well, this is not a fair question because I didn't give you a criterion. So if you answered no, then that would make sense because the criterion is a behavior that you would think would correlate with your score on this particular measurement. So for example, let's say that I think that the behavior that I want to be the criterion would be gift giving. That the more people feel like they overlap, the more they're going to give in gifts to another people. Gift giving is a behavior, it's a criterion. And I test if your answers to this correlate with gift giving, then that would be high criterion validity. I would assume that people who had a score of 1 way down here would give fewer gifts than somebody who is a 7 way up there who would give more gifts. Criterion, in this case, the behavior is the criterion. Okay, this is a good place to stop until part 2.